Okay, for lecture today, just wanted to go over the results of the third exam and also introduce the next homework assignments, exercise 10A and 10B on the extratropical cyclone and extratropical cyclone track weather. So, for the third exam, we had a total possible of 30. The high score this time around was a 29 out of 30. So, in looking at the grades through exam 3, we have high scores of 30, 30, 29, with the final yet to be taken. Homework through the third exam has a total possible of 181 points. So if you want to figure out how you're doing in homework, all you have to do is total up all of the points you've accumulated so far. So let's say, for example, you have 162 points so far out of a possible 181. And just take the 162 divided by 181 and you come up with 89%. I'm going to take that 89% and multiply it by 30, and that would imply that I'm getting 26.8 out of 30, which is rounded up to just a 27 out of 30. And so that gives you an idea of where you're standing in terms of your homework grade. If you have any questions over any of this, or would like to know, say for example, what do I need on the final exam to get a certain grade, just shoot me an email and I'd be happy to go over that with you and let you know where things stand for you so far. Okay, for the third exam, just reviewing some of the answers to the questions. Number 1, the amount of pressure exerted by the atmosphere depends on all of the above: mass of the air molecules, the force of gravity, and then the kinetic energy of the air molecules. Number 2, air pressure is not easily sensed by humans because it acts equally in all directions. That's true. Number 3, barometers are kept indoors, so changes in outdoor air temperature will not affect the measurement of air pressure. That's also true. Number 4, on a weather map, pressure units are in millibars. Number 5, the pressure gradient force acts in a direction of both A and C, perpendicular to the isobars and directly from high to low pressure. Number 6, the Coriolis force is a deflective force caused by the rotation of the Earth. Number 7, the geostrophic wind represents a balance between the pressure gradient and Coriolis force. Number 8, which of the following results when the force of friction is included? That's a resistance the wind encounters, so wind speed decreases. Number 9, surface winds in a northern hemisphere low pressure system are counterclockwise and in toward the center. 10, which of the following statements best describes the circulation of air near the center of a high pressure system? That's convergence aloft, sinking motions vertically, and divergence at the surface. Number 11, surface winds tend to blow across the isobars at an angle, while upper level winds tend to blow parallel to the contours. That is true. Number 12, looking at the surface map in slide 1, in which state would the winds be strongest? So, looking at the map for slide 1, you can see what we're looking for. The winds to be strongest was where the isobars are closest together, and so that would be up here in B, South Dakota. Then number 13, again looking at that same map, in which state would the winds be weakest? For that question, we're looking for where the isobars are farthest apart, and that would be here in A over Iowa. Number 14, looking at the surface map in slide 2, what is the wind direction at Fort Wayne? So now we move on to slide 2 here. We have low pressure off to the east, high pressure to the west, and with isobars oriented north-south along going through Fort Wayne. So you can either use this low pressure and counterclockwise across the isobars toward the low, or the high pressure clockwise across the isobars away from the high, and you'll come up with the same answer. So that counterclockwise going across the isobars at an angle would produce a northwest wind, just as you do clockwise across the isobars and away from the high. You get that same northwest wind. Number 15, looking at the map, what direction is the pressure gradient force pointing toward at Fort Wayne? So here we know that the pressure gradient force goes directly from high pressure towards low pressure, perpendicular to the isobars. So from here at Fort Wayne, it'd be oriented something like that, out to the northeast for my pressure gradient force. So that's the answer for number 15. Number 16, what direction is the Coriolis force pointing toward in Fort Wayne? So for the Coriolis force, we said that the wind is a northwest wind coming from the northwest. So, if I can move this properly, that would be a vector going toward the southeast. Coriolis force acts to the right and at a right angle to the wind direction. So going to the right and at a right angle to the wind would have a Coriolis force pointing down to the southwest. And so that's the answer for number 16. Then in number 17, what direction is friction pointing toward in Fort Wayne? We know that friction is oriented opposite to the wind, so going opposite from the wind would be pointing back toward the northwest. So the answer for the direction of friction is northwest. Number 18, looking at the 500 millibar map in slide 3, what is the decoded height of the station in central Illinois that is circled in red for you? So that one's right there. Height is 3-digit number. To decode it, you simply add a 0 onto the end of it, and it gives you the height in meters. So 548 would be decoded as 5,480 meters for number 18. Number 19, looking at the same 500 millibar map, the contours indicate there's a broad trough over the central U.S. And so here you can see that the trough carved out over much of the central United States, clearly indicated by the positioning of the height contours. Number 20, troughs on an upper air map tend to be associated with colder temperatures, while ridges tend to be associated with warmer temperatures. 21, looking at the meteogram in slide 4, during which time period was pressure falling? So now we go to the meteogram. Pressure is the last set of data down here at the bottom, and the time period during which it was falling is from 6Z on the 26th to 11Z on the 26th. And so that would be the answer for number 21. Looking at that same meteogram, a low pressure system was most likely approaching during which time period? A low pressure coming towards you would cause the pressure to decrease, and so the answer is the same as 21. That same time period when pressure is falling is when low pressure would be approaching you. 23, looking at the 300 millibar map in slide 5, use the method described in class to identify the position of the jet stream. Based on your analysis, the position of the jet stream indicated what? And we have an answer of a trough over the Great Lakes. So here you can see if you just identify the strongest wind speeds, and they dip down over here before coming back up there, so clearly defining a trough in the height contour field in the wind pattern at the 300 millibar level over the Great Lakes region. The position of the jet stream you determined in the previous question indicated a meridional flow, a rather high amplitude flow going more north-south rather than east-west when you look at that big trough carved out over the Great Lakes. 25. What is the main driving force for global circulation in the atmosphere? That is the unequal heating of the Earth's surface. 26. Which of the following is an assumption used in the development of the single-cell model for global circulation? All of the above. Uniform surface of water, always the equinox, and the Earth isn't rotating. 27. Primary wind belt found in the United States are the prevailing westerlies. 28. Cold temperatures near the poles would tend to result in high pressure, while warm temperatures near the equator, low pressure. 29. In global circulation, semi-permanent pressure systems develop over land, and seasonal pressure systems develop over the oceans. That's false, just the opposite. And finally, 30. Where would you tend to find the intertropical convergence zone? And that is found near the equator.